Welcome to today's workshop. James and Reed will be talking about drives and wheels. So thank you all for all coming on. I know we'll continue these at least through next week, and then we'll look and see how we're going to do from there. I hope these have been beneficial and some of y'all are getting a little bit of something out of them. At least we're staying connected and get to see other people's faces other than the same one or two that may be in your house. So with that, I will turn it over to James, and don't forget to record.
Yes, I started my record. Thanks, Brian. This is James. It's going to be an interesting thing today with me and Reed sharing. I'm going to start out. So I need to share my screen. It takes a moment. One of these days, it's just not going to get there. Looks like today's the day.
There it goes.
Yeah, I think maybe I need a new computer. So today's topic is drivetrains and wheels for First Tech Challenge robots. It's the number 5 of our workshops in the Quarantine Workshop Series. I am recording today, and I will post this on our YouTube channel and put the link in the Southeast Texas First Tech Challenge website. For those who don't know me, I'm James Wesselman. Me and Reed are First AmeriCorps Vistas. We are funded by the government to work with underserved and underrepresented communities, be involved with robots, and be able to participate in FIRST robotic programs. I am a retired controls and projects engineer, worked most of my career here in the Houston area in oil, gas, and chemical plants. I'll be co-presenting today with my fellow Vista Reed as well.
Hello.
So the content today is how important is the drivetrain, motivation of why we're doing the drivetrain, why it's the first thing we need in the mechanical part we believe that it's for you to understand, build well, have for future years. Desired features, I'll go on to that. Basic types. I'm going to go online to the Game Manual Zero website. Looks like it's a GitHub collaboration page that I'm grateful to Crystal Dalton for sharing with us, and it's just a good place to point you to and show you how you can use that resource as well. I'll go back to my recommendation. I will do a 1-question quiz, and then we'll go to Reed's Wide World of Wheels. Wild Wide World of Wheels. You're right, I couldn't get it done, Reed. All right. So first, why focus on the drivetrain? It's the foundation of the rest of the robot. You're not going to score any points if it doesn't move, and your robot can gain points for just moving. And I'll even emphasize here, the autonomous portion always has 5 points for you just moving a couple of feet. Therefore, getting a basic drivetrain up and running is the most significant first step in being ready to be in a First Tech Challenge competition. I also came up thinking yesterday, a consistent, reliable road driving robot is also a good alliance partner. I want to point out that if it doesn't work where controllably, or is it just dead sitting in the middle of the field and that's in the way of your alliance partner, that's not a good thing, and we want to avoid that. So, and that the basic drivetrain teaches most of the important lessons that you get from robotics: friction, torque versus speeds, motors and mechanical energy transfer, gears, sprocket, chains, belts, wheels, and more, which we'll touch base on as we go through this presentation today. So considerations: you want to build one that's reliable, that it's consistent. You want to build one that's agile, that can move around. Whether you want to stay out of your alliance partner's way, you want to play defense, which we don't look too fondly on in FTC, or if you want to be able to get to and from the game elements to where you put the game elements in a typical season, that agility is going to help. Whether you need traction or pushing power, it's particularly the traction is very important to me, as I'll explain in one of the versions. Torque versus speed comes into play there. We'll get into a little bit about gear ratios. I'm most probably going to cover that in my quiz question. Consideration of number and type of motors. You can increase your reliability, increase your traction with number of motors, but the trade-off is that costs you more money and you use up more outputs on your hub. And also, what sort of power transfer are you going to do? You're going to directly attach the motors to the shaft that goes to the wheels. Will you do it through a gear, a series of gears, chains, or belts with also additional gearing involved? So there's the basic types and options. There's two main types, and the game manual that I'm about to jump to breaks it out this way as well. I'm following it. You have tank drive, the classic version, and holonomic. Tank steer, brake, reverses one side, brakes or reverses one side of your wheels while driving the other to turn. And it's one of those basic lessons, the first lessons we learn in doing robotics. Of the tank drives, there's the different versions really go in the number of wheels. There's the two-wheel as part of the basic bot design. It's simple to build, inexpensive, easy to program. It has poor traction and less reliable, and I'll revisit that in a moment on the game manual page. Four-wheel is better, especially if you put a motor on every of the wheels. You get more reliability because if one motor goes out, you still have the other motor on that side to drive. You're also more stable. You got more weight at the bottom if you put the four motors. Six-wheel and West Coast Drive in particular, I say good enough. When I say good enough, I actually mean that's my selection of things. It's got great traction and power. Once built correctly, it's reliable, easy to program. It is harder to build, more parts, more cost. And compared to other ones, it may not steer as well, but it is more agile when it comes to climbing. Versus, and the last type is holonomic drives. You'll individually drive the four wheels in any direction, which means you have to have four motors, which means you're going to take up all of the outputs on your basic hub. It's also known as strafing or swerve. It uses mechanism omni wheels. Again, I'm repeating the four wheels and four motors. Reed will will tell you more about the wheels. It's more expensive. It's more difficult to program. And I don't think I didn't finish the statement there that the traction is not necessarily better than the six-wheel version. It depends on what you're trying to do. And we have like the balancing stone 3 years ago, or if you were trying to get into the crater last year, they're going to have more difficulty climbing over obstacles of that kind. So I'm going to go to game manual. And I'm in the wrong place for the game manual for me to start. So we were going to be on drivetrains. Now the game manual, I will post this when I'm finished. Again, this link is a great reference for the hardware for building your basic FTC robots and beyond, with some pictures and whatnot. Like I said, it's a collaboration. The contributors seem to be from all over the country, including a former or current team member of a team in California, Lincoln Robotics, that I'm the mentor for. So I think this means that you can contribute to it as well. If you have input, check into that if y'all want a chance for outreach. Anyway, so this is telling us about drivetrains. It's a good read. Taking it from the same kind that we have the two different types, the tank and the holonomic. And I covered what I said considerations. They have under how to choose a drivetrain, get into reliability, and they start to point to specifics. They're pointing out that the spur gear motors are not an optimal choice. And a quick thing, spur gear motors are the one with the shaft that's offset. planetary are the ones that the shaft comes out of the center of the gearbox. And both of these have gears. And in general, spur gear motors are kind of weak, but they're inexpensive and readily available. It's what Tetrix gives you, so it's what you usually end up working with anyway. Points on agility, what that means, speed and whatnot. They have a calculator for what torque you need, what gear ratio you may need, and this calculator here. But here we discuss number of motors and gear ratios. And I am wanting to point out that this is a great resource when you're deciding what motor you're going to put to your wheel. It recommends a 20-to-1 and 4-inch wheels. Go ahead and read this statement here to understand that. It also reiterates the recommendation to use planetary gearboxes over spur gearboxes. And the many reasons I stop and point this, my quiz, I'm going to talk about gear ratios outside the motor. This ratio is the ratio of the motor. Basically, the higher the gear ratio here, the more torque and lower the speed. And we're going to cover that a little bit more in the quiz question. Traction versus and pushing power. I like this. And they say, well, this feature is often overemphasized. I think it's often missed. In particular, when we talk about the two-wheel robot and your basic robot, how important traction is. If you don't see your wheels spinning, you think your robot's not working at all. And you're maybe thinking you've got communication problems, you have some other power problems, and yet it's just your wheels aren't moving because they're slipping against the surface. So I think it can't be that it's underemphasized. But here I'm sure they have their reasons for seeing it as overemphasized, mostly because, trying to push things isn't that important. They also discuss the different methods of powering the drivetrain again, which I'm not typically going too much into, but why I'm pointing to this. So you come here and you drill into their power transmission for more details. You'll get more information. I again like the fact that they point out, similar preferences to us. We don't like Tetrix gears. We prefer the Rev plastic gears are better. And that it recovers those. So I want to cover then the different tank skids, the two-wheel push-bike drive, and again, it's a good first drivetrain to learn from, but not necessarily good for competition. This is where I come back and restate what I said earlier, mainly because that two-wheel does not have good traction. If you don't have good traction, you're not agile, you're not maneuverable, you're not consistent in driving. And they even say it again here, while the pushbot's good first drivetrain for new teams to get acquainted with their kits, it's recommended you get to move away from. And I think the point of this training is to give you an idea of what you can do with your resources to move away from that, to get the next best step up, but maybe not be too ambitious. And there, of course, is the picture of a basic two-wheel bot with the push bot, four-wheel drive. There's two ways you can do the four-wheel drive up front. If you just have four wheels, you can put motor for each wheel. If you can afford to use all of your outputs on this, it is definitely a great way to do it. It gives you a lot more flexibility and even steering, but definitely in traction. You get more weight that way. The worn turning can be slightly slower on four wheels than their 6 or 8 wheel counterparts. So here again, they give the advantages. That solid acceleration and traction is the main advantage they give for it. And then that also increases that if you need to push, that you get more push. It's still not as stable as 6 wheels. And it can, depending on how you do the four-wheel drive, you can decrease your maneuverability, etc. So here we got some pictures. I like this first picture is a different kind of power distribution. They're using a compliant wheel to friction push the front and back wheels, but that gets you 4 wheels driven, and those wheels can be bigger that way, I think is the reason. Another method of having the motors driven by a chain or a belt. This is the robot. And you see that not exactly what my idea of a basic year-to-year bot, but what they're showing in this CAD is that this can be used. This was the picture in this case looks like it was for Vortex for the game about 3 years ago. But if you remove that center part, you can have different intakes, lifts built around it. This is showing 4 motors, 4 wheels with Omni wheels in the front to increase your steering. My favorite is going to be a 6-wheel drive. I like it with a drop center, as suggested here. I've also done with a drop center, and I still had the corner Omnis. That way it designated my front. It is stable. It gives you lots of traction. You can still do it with just 2 motors if you connect all the wheels with a chain, belt, or gears. Or you can attach 2 motors into that drivetrain. I'm going to show a picture of why I like this even better, and I've already covered how much I like it. Depends on the motor, but you can still get good acceleration and then have a high type speed if you choose correctly. It's stable, it's consistent, so it's agile, which also makes it good for defense that they state here. Again, I have to remind you though, in FTC, it's not defense is not really favorably looked upon by referees sometimes. More so out my old area than here, I think. The disadvantage is that building it is more difficult. Dropping the center is a little tricky, but once you do that, it ends up being a consistent, reliable robot. The turning is worse, but any system's going to have its limitations. Once you get used to how it turns, whether you're programming it or driving it, that sort of disappears in my thinking. They say it's dependent on field conditions, and I have to say that, yeah, it's definitely more desirable if you need to climb, if we have raised obstacles. And that's what but be warned, if you get the wrong gear ratios, it'll be slower. This is a picture of a 6-wheel bot, and my favorite types of wheels for a 6-wheel bot. They seem to be slower, but no matter what, it definitely gives you the best traction and the best reliability, consistency. Is these 4-inch friction wheels. They show different ways of driving them through 2 motors combined into a gear system. This is the 4-wheel. They also bring up 8-wheel. I don't know if I ever can remember seeing one. You don't see them a lot in FTC. An 18-inch robot doesn't give you a lot of space to put 8 wheels. You got to drop down to a 3-inch wheel, basically. But again, the advantage starts to be even more traction, more stability, and more options for doing the motors. There's different ones. Then on the holonomic drives, which is I don't have as much experience with, and the Go Build the version here last year was very popular. They were selling this kit quite inexpensively, therefore it was being picked up a lot. It requires mechanism wheels or Omni wheels. And the one I'll get down to in holonomic drives, because I'm running a bit long and I want to give Reed his time, is the H drive, and because I think he'll cover it. But it's one as a version of being able to strafe or to move in any direction. One option is the simplest. These wheels should be Omni wheels, but basically you have just 4 Omni wheels going frontwards and back, and another wheel or set of wheels that push you left and right. Having said that, I'm going to go back to I did want to do my quiz, and I can't seem to find it now. Sorry about that. I already said what my favorite was and why, and I don't have time to show you a video on it. The one additional thing is one of the reasons I came to realize that it was a good one was I had seen it win 2 years in a row in the World Champion Series here in Houston at the George R. Brown for FTC. the Redneck Robotics from Montana had a basic Hollywood drive, but I shouldn't say basic, an enhanced. They built it well with the 4-inch friction wells, and it just, because it's reliability and they had good programming, the consistency and whatnot, they were able to win at the highest of levels. So I have a quiz. You wish to increase your robot speed. Which ratio of gear teeth from motor to wheel will best accomplish the goal? And as usual,
please put your answer in the chat, please. Your answer choice letter. Ooh, that means y'all not sure.
It went away.
James, you brought the Zoom meeting back.
Okay. No, I'm sorry, because I wanted to see the chats and I forgot how to do that. I need 2 computers. I'm just too lazy to set the other one up. It's right there. So what's the any answers?
So the average answer right now is D so far.
D.
Yes.
And me and Reed agree. Actually, this is kind of quite difficult, and if it wasn't for other, and since I wasn't really talking about it.
We got a couple B's that came in, a couple A's that came in. A couple more B's and a couple more C's.
It's a sort of problem I have a lot of problem with. I'll go ahead and cover the answer. The answer is A. And reiterate the question is, I am trying to increase the speed with a particular motor. Whether I chose the 20-to-1, the 40-to-1, or the 60-to-1, I turn around, that's the only motor I have, and I want to speed my robot up. So what I do is I want to increase the number of turns the wheel makes for the number of turns the motor makes, to do this simple. And so of these different ones, all these ratios break down real quickly. You divide them down. 30-90 is 1-to-3. 90-30 is 3-to-1. 60-120, although it looks like different or bigger numbers, it's 1-to-2 and 2-to-1. So if you look at these, which one do we get for the most revolutions, wheel revolutions, for the number of motor revolutions? And that's A. So having done that, and hopefully having kind of given you a perspective on how to think about these things and in mechanics, I'm now going to turn it over to Reed. And I think I took a little bit too much time.
No, you're good. So before I go into my section, we had a good question from the other James. He said, is it still 4-wheel drive if there are only 2 motors? Wouldn't the power be slower or lower? Yes, it's still 2-wheel drive, but it technically is 4-wheel drive now, because now you have power going to all 4 of your wheels. So, at least in my opinion. So,
not quite sure how it depends on how you configure. Just wanted to understand, is a 4-wheel if there are only 2 motors? Yeah, yes, it is. It's when we in our discussions here, 4-wheel drive, it's the same as a car. You have 1 motor, but you can have 4-wheel drive. It's how the wheels are driven. And then you can have different types of 4-wheel drive in a car. You can sort of have 4 different kinds with the robot as well. But I do the 6-wheel with 2 motors, 1 for each side. And if I was to do it with 4 motors, I would most probably just combine the motors into a gear box and distribute the power. I'd just be trying to add power by adding the motors. So yes, it's still. Will the power be lower than if you had 4 motors? Yeah. The biggest reason to add the other 2 motors isn't is powering the other 2 wheels. It's to be adding power. So that you don't slow down in speed when to increase your acceleration and everything else. The reason that you add power, which is different than torque, but I haven't got time to cover that here.
Okay, so now we are on the wheels. Unless anybody has any more questions about drivetrain before I start on wheels. If you do, speak now or forever hold your peace.
Got a lot of comments. The presentations themselves we posted to addition to the recording. Not on the website. Brian will mail those out to everyone. I just need to be reminded at the end of the presentation to give him the presentation. Is there any way we can print out your PowerPoint for future reference? If you, Brian will send you the email. Can we see some pictures of the basic type of drivetrains? Let me leave that to try to get to that. The traction for holonomic would be better. What was that? Would be a fair bit worse than 6 zeros, wouldn't it? Yes, that is my feeling for it. That having those slanted wheels, their traction's a little less. So let Reed have it.
So before we start, I'm gonna play a quick video on wheels real fast. It's 2 minutes. Oops. Okay.
In this video, we are going to talk about different types of wheels. The first wheel is a traction wheel. This does not move in any other direction other than the way it is moved by a motor. This wheel is the same thickness as a rev extrusion. It also has a hex hub, which makes it very easy to attach rev axles to it. This is an anti-mark stealth wheel. This wheel has a round hub, which means it is necessary to use a set screw hub. The set screw hub can be attached using screws. In order to attach an axle, insert the axle and tighten the set screw. This is an anti-mark compliant wheel. It is very helpful for intakes, but is not really helpful for driving because it is so squishy. Similarly to the anti-mark stealth wheel, you also need to use a set screw hub to secure this wheel. You also insert an axle and tighten the set screw in order to secure it to an axle. This is an omni wheel. It can move both sidewards and forwards and backwards. These wheels are very helpful for non-powered wheels on a robot. This is a mechanism wheel. It is very special because it can help a robot move sidewards as well as forwards and backwards. This wheel is made up of many rollers, and if you use 2 of them and turn them against each other, the robot will move sidewards. Here is how mechanism wheels work when used on a robot.
Okay, so now that everybody has a quick understanding of the few different types of wheels that there are, let me change my camera. Can you see this? Okay, so I have a few different types of wheels. I have the new Go Builder wheel, which is comparing it to the regular Tetrix Pitsco wheels. You can automatically see the main difference. It's twice as thick, twice as heavy, a lot more holes. You have the mechanism wheels, as you saw in the video. This is the Actobotix ones. You have the who is this again? Is this?
I think those were Actobotix.
You heard her, Actobotix. And then you have the other. So there are 2 types of the stealth wheels. There's the one that comes with the, as you can see, the 5 holes for the hub attachment. But then there's also the version where it comes with a giant hex, centerpiece that's about an inch wide. For this specific wheel, you have to have a transfer plate, so that way you can connect and still connect to your robot. Now, preference-wise, if starting as a rookie team, I always would recommend using mechanical wheels. Omni wheels, not mechanical wheels, because they're omnidirectional. As you saw in the video, they can go any direction. You can help them, especially when you're using the push bot for the 2-wheel drive or even for the 4-wheel drive. You can still use omni wheels. It is better to stack omni wheels together, as you can see here. It's still 2 sets, but you get a better feel of maneuverability, and you don't get as much slipping and sliding off of the robot. Now I want to go into I also want to talk about, because James didn't really get into it, you also have the tank drive set up too. There we go. So as you see, you have a motor, which is directly at the top center for its tension wire. You have 2 sprockets on the very end that connect to the outside, so that way you have your bottom, and then you have 1 more tension wire at the bottom to just keep it running straight and doesn't slip up. Tank drive, this is a actual tank drive, and not just the tank drive that you would do programming in your computer. It's not a bad design to use, but I don't recommend rookies or even teams that have been around for 3 or 4 years to use tank drives, because it's not very adaptable to the game every year. And even if you believe that it might be for that year, there's usually complications that come with it because of the game, where there's trying to get over pieces, trying to collect field pieces, and also trying to get that tension into the wire and take out the looseness is a little difficult, because it's also very tedious and very plastic, so they kind of break pretty easily too. You also have, pass. As James discussed, you still, oh wait, you can't see that. You still have the regular chain, You still have the gear ratio drive that James was talking about. This is the EduBot, the Rev EduBot, which is still a 2-wheel drive, but the Rev MiniBot, which we just finished building 2 days ago.
So Reed, on that one, that looked like that was 1-to-1 gear ratio.
Yes.
What was the motor gear ratio?
It's a 40-to-1.
It's a slow but steady.
Yes, it is a medium. I call that a medium gear motor, because you have, as James said earlier, you have the smaller the number, the faster the motor, but the less the torque. The bigger the number, the slower the motor, but the more torque you have. So in this case, this is, you can see this. This is the Rev MiniBot. You can see it has the 3-to-1. So you have 1 motor that sits in the very back. Oh yeah, I'm backwards. So as you can see, there's 2 motors in the back that connect to the first 2 gears, that then connect to the 2 center gears, that then go to the 2 front gears to run the robot. So you still have, in this case, a 4-wheel drive and almost a 6-wheel drive if you want to add 1 more wheel in the middle.
And what does it look like on the underside?
Yeah, do that. Turn it over.
Like this. Oh, you smart.
And I'll point out that if you could move the motor to drive the gear, the transfer gear, you would speed the robot up.
So one thing that I definitely do not recommend, unless you were like, you have somebody dedicated directly to programming and dedicated to learning how to work mechanical wheels, I recommend not using mechanical wheels, because it is very difficult to use, and you have to make custom programming directly for mechanical wheels. Unlike, mechanical wheels are very close to an H drive, which is my favorite form of drivetrain, because as James said earlier, you can go almost any direction. You go forward and backwards, but you can also go left to right, because you have that center motor and that center 2 wheels, so that help you change your direction. Now, as you can see, You have, these are the different types of other wheels. You have the Omni wheels, so you have the big bulky Omni wheels. They have plastic and they also have metal Omni wheels. And then you have the original Mechanism wheels, which are trash. And then you have, let me see if I can show you better on my main camera. Does that look better? Okay.
Yeah.
So you have, there we go. Am I too bright? Nope, too dark. Sorry about technical difficulties. You also have the other wheels, and then you also have the compliant wheels. Compliant wheels are the green wheels that you saw earlier. There are 3 different levels of compliant wheels. That you have the green ones, which are the softest and very squishy / malleable. You have the purple, which is a little bit more stiffer. You can still bend it and do things with it, but it's a lot stiffer than the green ones. And then you have the blue ones, which are the thickest. They're more malleable than the Tetrix Pitsco wheels and the stealth wheels, but you still get a little bit more flex in the wheels to use. So it is better to use for a intake. Compliant wheels are better to use for intakes than instead of for drivetrain. I hope I answered all my questions. Are there any questions?
They got signed there, Brian. What is the purpose of the compliant wheels? They're used for intakes. They're pliant, they're flexible. And when you're wanting to grab game elements, if you try to use a normal wheel with no flexibility in them at all, you have to build it very specific to the size. And then when you're grabbing it, you have to hit it very specifically for it to pull in and work. The compliant with that little bit of pliancy gives you some ability. You'll find out you still need to put it on a bar with some more springiness in order for it to work. But it's usually, yes, for a moving grab. When we use an active intake is one with wheels that will move, will grab your game elements into your robot.
I'm gonna share my screen real fast.
And we were discussing those yesterday in Q&A.
Yes. So this is a picture of my my FTC team, my boys team from last year. I guess from this season technically. We have an H drive. So can I annotate? Yes, I can. So we have a chain drive going on both of our wheels. So they go from a 2-wheel drive to a 4-wheel drive. We also have an H drive. So we have 2 wheels, as you can see, in the direct center of our robot to help us change direction. You don't really, unlike the mechanical wheels, you more glide when you're driving with mechanical wheels. With the H drive, you're more of just going back and forth and then left to right. You're not really gliding and smoothing everywhere like a moon rover. It'd be cool, but it's a little bit more. They're more difficult to use, and it takes a lot more skill to use mechanical wheels. All right, can I clear this? Wait, how do I clear this? Okay, there we go.